Let's settle down and let's have a discussion about this question. Now, of course, the exam is done, so move on. Put it behind us, move on. It's frustrating that there was such a horrible question at the end, and in exam conditions, I've no idea why they expected this to be a good question, but anyway, don't worry if you didn't do it. It's absolutely fine. You know, it's a tough question. We'll go through it here. You might kick yourself in the foot, you might not. I'm not bothered, it's absolutely fine. Well done for doing the exam anyway. Okay, we have 3 circles. First thing we notice is that all the 3 circles have the same radius. They have the same radius, so they have equal area. This is a length of 4 from the centre of the middle to the circumference. Here, this is the centre of this outer circle, so it's got a radius of 4. Same idea for that outer circle. The first thing I'm going to draw on is another radius. Why am I going to do that? Well, because it creates a certain type of shape. From this centre of the outside circle, if I draw that line on there, it reaches the circumference and it's where the circles cross. What shape have I created there? Anybody? A sector. Did you write that in the exam? No? Oh, never mind. Okay, so we've created a sector. Now, I'm also going to draw this line on here from the centre of the middle circle to that point there. What's the length of the red line and the green line? They're both 4. Did you write that in the exam? No? Oh, well, they're both 4 because this red line is the radius of this outside circle, which is 4, and that green line is the radius of the inside middle circle, which is also 4. So what shape now have I created? Epic. An equilateral triangle. What do we know about angles in an equilateral triangle? They're equal to 60. Who just said they're equal to 40? Hope you didn't write that in the exam. Oh, I wrote 40. Okay, 60. So what I can do is I can work out the area of the sector, I can work out the area of the equilateral triangle, and then I can do some subtraction. But the first thing I'm going to do is just work out the area of one circle. That's pi times 4 squared, that's 16 pi. Probably 1 mark for that. Then I'm going to work out the area of the sector here, this sector. It's 60 degrees of the full circle, so area of the sector. 60 out of the full 360 times the area here, 16 pi. That's a 1/6 of 16 pi, that's 8 pi over 3. I'm then going to work out the area of the equilateral triangle. I'm going to call that the E triangle for short. A couple of ways you can do this. You could use Pythagoras or you could use half AB sine C. I went for that because I'm a bit fancy. That's 16 over 2, which is 8, times sine of the angle 60. You had to know your exact values for that. It was on the information. So that is 8 times root 3 over 2. Sine 60 is root 3 over 2. That's 4 root 3. So the area of this green triangle is 4 root 3. I've then worked out the area of that sector there. Why is that useful? Well, because I can now work out the area of this bit here, the bit that's in the sector, but not in the equilateral triangle. So to work out that bit, we'll shade it in really, really dark. That shaded bit there, what will I do? I will do the sector, which is 8 pi over 3, subtract the equilateral triangle, which is 4 root 3. So that's the area of that bit. Now what I'm going to look at is, I'm going to look at the semicircle. So this tells me here that the semicircle area is a half of it. It's 8 pi. So this area here, all the way along, is a semicircle. What bit of the shaded, which bit of that is shaded? It's this bit in here. So what it is not, look, this is 4, is the sector, an equilateral triangle, another equilateral triangle, and then the sector. Minus these 2 bits. So how do I work that out? The top shaded region, so I'll call it the top bit, okay? It's the semicircle, which is 8 pi. And then take away everything that it's not. So it's 2 lots of the sector, because I've got a sector here that's the same sector here. So minus 2 lots of the sector, 8 pi over 3. Plus this bit here and that bit there. And we know what that bit is because we've worked it out. It's the same as this bit here, just looking at the sector from a different way. So it's take away 2 lots of this. So take away 2 lots of this plus this bit here. This is horrid. So what have we got now? We've got 8 pi minus 2 lots of this. Add those, 16 pi over 3 minus 4 root 3. So let's simplify that. 8 I can write as 24 over 3 because I've got a minus 3 in a minute. Subtract 2 times 16, that's 32. We've got a pi on the end, we've got a 3. Is equal to 4 root 3. Okay. Have I done this right? I hope I have. Yes. Yes. Good. Okay. Is that right? Yes. So we've now got down to this. Subtract. That's an 8. Plus. We'll get there. Plus 8. This is then minus 8 over 3 pi plus 8 root 3. Oh my God, are they trying to kill us? Right, so then we've got the top shaded area. How did I do it? I took the semicircle. I subtracted 2 lots of these sectors because there's 1 there and there's 1 there. So that's that bit. I'm subtracting 2. And I've subtracted 2 lots of these bits. That's just the top bit. It's the same over here because it's just the semicircle. So then I take this and I say 2 lots of it minus 8 over 3 pi plus 8 over 3. That's minus 16 over 3 pi plus 16 root 3. And that is your answer. Oh!